then practical session उसको प्रीपोन दिया मैंने दिया हाँ
क्लास 10 बाद शुरू करेंगे
क्लास के बाद लंच होगा दिस क्लास फ्रॉम 11 to 12:30 12:45 12:45 to 1:30 lunch 1:30 to 4:30 practical technology department छोड़ने
ठीक है नहीं जरूरत नहीं
Yes, बच्चों, let us start. कौन? शुरू करें? दिव्यांशु. सर इसमें चलिए ऑफसाइड का चलिए कौन पढ़ने वाला है इसको
सर वो रोटेट करने
कोशिश करो पर डोंट टेक मच टाइम इधर गो आएगा
विंडो में
यस बोलना नहीं
if you forget it and this spirit of hope and achievement. You are here to more amply with greater vision bigger inner are here in order to enable your body to find to live. You are not here
नेक्स्ट बात चलो अभी एक और ट्राई करो
the पढ़िए
यस
than a perfect plan executed now is better a good plan voluntary.
एक और see the next one. Two pictures, one more. Yes, try to play.
Impressive thing is the beginning. It was hard, but your mind is ready automatically without even thinking about it. Proud. Tablet please forward if you can listen. Yes, sir, पढ़ लिया. मैं पढ़ लिया.
Sir, एक और one more. So now you have seen that. Yes, boy. You have seen that. Okay. And after going through that, let us do one exercise. But before exercise, just try to touch your chin. So, but you can confuse. Most of the time, our mind is conditioned. So this conditioning is important for playing while we are studying. Okay. But before starting, there are certain things which are indirectly associated with our learning. Let us do one little experiment with Goa. It is just a kind of fun activity. Don't mind us. मेरे पास ठीक है बोल के देखो
Hello, hello.
बहुत she knows ABCD आता है ABCD say yes
Yes,
perfect
yes.
हाँ तो अभी ये गोहर आपको जेड से ए तक सुनाने वाली है तेजी से अभी जो अभी तो तुमने बोला ABCD आता है
Sir, A to Z.
तुमने रिवर्स नहीं सीखा फिर क्या सीखा चलिए कौन कौन ट्राई करेगा रिवर्स चलो बट रुकना नहीं है जो रुकेगा वो सबको भी कुछ चॉकलेट वॉकलेट खिलाएगा
Z Y X W V U T S.
थैंक यू
Just Siddharth.
देखिए होता क्या है जब भी हम पढ़ते हैं ना हमारा माइंड बहुत ज्यादा कंडीशनड हो जाता है और इस कंडीशनिंग का फायदा कौन सा इंडस्ट्री लेता है मार्केट ठीक है दे आर कंडीशनिंग आवर माइंड हाथ धोना है तो किससे धोना है डेटॉल से धोना है ठीक है ऐसा तो दिस इज हैविंग हाई इम्पैक्ट ऑन आवर माइंड so this is one part but before moving further let us have certain things that I want to ask okay that you can respond in a free way that responding is important okay that responding is important it should be a non judgmental responding हमें अपने को जज नहीं करना, मैं भी आपको कोई जज नहीं कर रहा हूँ। आप में से कितने लोग अर्ली राइजर है, सुबह उठ के पढ़ाई करते हैं? उठ जाते हैं 4 बजे, 3 बजे, 5 बजे, किसी को दिखाना भी नहीं है। हाँ तो हाँ, नहीं तो ना, कोई फर्क नहीं पड़ता। 4 to 5, 4 to 5:30।
एग्जाम्स
और 3 बजे सोने वाले कितने हैं? 2 से 3 बजे सोने वाले कितने लोग हैं? 2 से 3 बजे हम लोग पढ़ते पढ़ते रहते हैं, 2 बज जाता है। ठीक है। अच्छा, जो लोग 2 बजे तक पढ़ते हैं वो शायद 12 बजे पढ़ना शुरू करते हैं। चलो एक और चीज के बारे में थोड़ा तुम्हारे सामने एक सर्वे में बताता हूँ, ठीक है ना? कोई भी आ जाओ इधर, सिद्धार्थ से ही बात करेंगे आप। कोई जजमेंट नहीं है, नो जजमेंट एट ऑल, जस्ट वी आर टॉकिंग, बट दीज थिंग्स आर गोइंग टू हेल्पफुल। व्हाट टाइम यू स्टार्ट योर स्टडीज?
सर शाम को 7-8 बजे। दोपहर में दोपहर में 3-4 बजे, फिर शाम तक, फिर वापस रात 8 से 10।
अच्छा, आउट ऑफ यू हाउ मेनी आर एग्रीइंग ओवर द पॉइंट कि रात को बहुत अच्छा पढ़ाई होता है? कोई जजमेंट नहीं, केवल एक बार प्रॉम्प्ट आंसर करना है। तो रात में बहुत अच्छा पढ़ाई होता है। बट इट इज नॉट ए ट्रू फैक्ट। हमारा माइंड ऑलरेडी इतना ओवरवेल्म्ड होता है, हमें लगता है कि बहुत ज्यादा पढ़ाई हुआ, पर रिटेंशन बहुत कम होता है। ठीक। अच्छा, तुम में से ये वाला फैक्ट किसको पता है? यू नो द भिंडी, लेडी फिंगर, उसको खाने से मैथमेटिकल एबिलिटी बढ़ती है।
करेला खाने से
नहीं नहीं पता। दिस इज अ गुड फैक्ट। चलिए ठीक है, एक बात और सीखते हैं। एक बात और सीखते हैं। There are two words. There are two words: resting and relaxing. Resting and relaxing. ठीक है? तो he is our prototype from your side. ठीक है ना? But I want to know, सब थोड़ा एक मिनट दिमाग में सोचेंगे कि हम रेस्ट या रिलैक्स करने के लिए क्या करते हैं। सबकी अपनी अपनी हॉबीज होंगी। Just recall in your mind. कोई गाना सुनता होगा, कोई डांस करता होगा, किसी को साइकिलिंग पसंद होगा। ठीक है? तो इसी के लिए एक एक्सरसाइज करते हैं। अपने हाथ ऐसे कर लो, ठीक है ना? हाथ इधर ही है ना? अपने हाथ ऐसे करने हैं और इसको ऐसे करना है, ठीक है ना? स्टॉप, जस्ट स्टार्ट, स्टॉप, स्टॉप, स्टार्ट, 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 स्टॉप। ठीक है? अभी इसका रिवर्स करना है, ऐसा एकदम बहुत तेजी से ओपन करना है ना? स्टार्ट, ब्लिंक हो रहा है ना? स्टॉप। अभी राइट हैंड को, केवल राइट हैंड को करना है, ठीक है? केवल राइट हैंड को करना है, लेफ्ट को नहीं करना। यू नो ना योर राइट और लेफ्ट। स्टार्ट, स्टॉप, स्टार्ट विद लेफ्ट, स्टॉप। कुछ कोऑर्डिनेशन हुआ? You have to develop this coordination. और मैं दो तीन चैलेंज तुम्हें बता रहा हूँ। हाँ कोऑर्डिनेशन है। अभी मैं दो तीन चैलेंज बता रहा हूँ, देन वी आर स्टार्टिंग। नंबर 1, देयर इज अ वन कॉन्सेप्ट, दिस इज कॉल्ड आईक्यू। सबको पता है आईक्यू, राइट? देन सम ऑफ यू आर आल्सो नोइंग ईक्यू, इमोशनल क्वेश्चन। ठीक है, इमोशनल क्वेश्चन इज रिलेटेड टू दैट कि सिद्धार्थ को उसके दोस्त ने कुछ बोल दिया, वो 4 दिन तक कोई बात ही नहीं कर रहा है, ठीक है ना? बट अच्छा ईक्यू क्या है? ठीक है, बात की, बोल दिया, वी आर ट्राइंग टू अंडरस्टैंड द पॉइंट ऑफ व्यू, बट वी आर रिजॉल्विंग, वी आर मेंटेनिंग अवर फ्रेंडशिप। नाउ द थर्ड वन इज SQ. This is spiritual question. Which question?
Spiritual
question. ठीक है, that is more significant. वो क्या है? ठीक है, उसने बोला we try to understand, but still we are giving our right opinion. That is the main thing. These are the role playing things, but simultaneously there is a one good thing which we all are forgetting. Let me put focus there. You know the fuel used in aeroplane, okay? The fuel which is used in satellites and the fuel used in bike and car. जितना हमें हाई फ्लाई करना है, उतना हमारा हाई क्वालिटी का क्या होना चाहिए? फ्यूल होना चाहिए, ठीक है? तो कैन बी मेंटेन फ्यूल। चाउमीन खा के फ्लाई कर सकते हैं क्या? नहीं कर सकते। हमारे बॉडी में ऐसे सेंसर्स हैं, if we are taking a high quality protein nutrition, these nutrients are helpful in our study. It is a proven fact. It is a proven fact. But the other types of food stuff which are not totally helpful, they are drifting in different directions. We should be little bit selective while we are doing with our food. These are the certain important things where I brought your focus. पर मेरा अभी कुछ और भी लंबा सर्वे है, वो नहीं करेंगे. Let us focus on the application of the redox reaction, the redox to open cell. Redox. But during this process, अपना लेफ्ट हैंड ऊपर करो, ठीक है? और इसको ऐसे ऐसे करके रखना है, ठीक है? हाथ नीचे करो, हाथ नीचे करके बस ऐसे करके रखना है, ठीक है? चैलेंज है बहुत। करके लो, बट अपना फोकस उधर डाइवर्ट मत होने दो, तब वो ऊपर जाएगा, ठीक है ना? हाँ, लेफ्ट, हाँ लेफ्ट से, राइट से लिखते हैं, लेफ्ट से लिखते हैं, जो मैं फ्री उससे कर सकते हैं। सर वो और ऊपर जाएंगे, काफी और काफी ऊपर, काफी ऊपर। के बाद इलेक्ट्रोकेमिकल से नहीं जाएगा। यस सर, इसको डायग्राम को सर थोड़ा सा टिल्ट करके नाउ और फोकस है। यस, ऑब्जर्व इट केयरफुली, देन वी आर गोइंग टू स्टार्ट। थोड़ा स्ट्रेन बैठ के करेंगे ना, एनर्जी फ्लो अच्छा होगा, योर रिटेंशन विल बी हायर। सर थोड़ा नीचे आएंगे इसमें, ठीक है सर, उसको छोड़ा। Yes. Now try to understand the concept we are going to deal, that is called electrochemical cells. Okay. The cells in our day-to-day life we are dealing batteries, cells that may be cell used in computers. That battery is called CMOS, CMOS battery. Then we are a lot of type of the cells batteries you have seen in mobile, but all are fundamentally working on this simple concept. Okay. Now I am just telling to draw a diagram in your notebook. Make a beaker. Make a beaker. Draw a beaker. ठीक है, बीकर बनाओ, कंजूसी से मत बना, अच्छा बड़ा वाला बीकर बनाना। ठीक है, बनाया, छोटा ट्रे हो, हाँ बड़े वाला बीकर बना, 500 ml कैपेसिटी। यस, एक बीकर ड्रॉ करो, ड्रॉ बीकर, single beaker, only single beaker, right? In that beaker, in the middle, put a strip, electrode, जैसा इसमें लगाओ, उसके सेंटर में एक बीकर बनाया, फर्स्ट स्टेप, बीकर के सेंटर में एक स्ट्रिप या इलेक्ट्रोड ऐसा ड्रॉ करो।
ये इलेक्ट्रोड है ना?
यस, दिस कॉल्ड, ठीक है। ये ऐसा नोटबुक है, ठीक है, हमने इलेक्ट्रोड ड्रॉ किया, ठीक है। अभी इधर थोड़ा ऐसा डैश 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 लगाओ और here you write CuSO4 aqueous blue, CuSO4 aqueous blue, एक इलेक्ट्रोड ड्रॉ करो। I am working on your visualization based, not just based on that. And the content in the beaker is copper sulfate, CuSO4 aqueous, color is blue, you know the copper sulfate. And the rod, indicate the rod, electrodes, zinc, zinc electrode. The name of electrode is zinc electrode. Right? Just imagine this experiment.
So जिंक इलेक्ट्रोड,
हाँ zinc electrode. Imagine this. अभी मैं इसको लेके थोड़ा समझाने की कोशिश करूँगा, ठीक है? ये हमारे पास में एक बीकर है। Imagine करो, this is the very first step. This is a beaker. In that beaker, we are having an electrode of zinc, and that beaker is containing copper sulfate aqueous solution. Means copper 2 plus ions are separated, sulfate ions are separate. We are dipping a zinc electrode. Okay, the situation is clear. Can you visualize it? Is there any problem?
No.
Right. Then what will starts to happen when we are dipping it? Write the equation zinc ब्रैकेट में सॉलिड, जिंक ब्रैकेट में सॉलिड, जिंक मतलब Z है, तो राइट Z है, सॉलिड गिविंग कहीं भी लिखो, कॉपी में लिखोगे, हवा में नहीं लिख सकते। जिंक सॉलिड गिविंग मींस एरो Zn2 plus aqueous plus 2 electron equation will be oxidation or reduction. It is giving electron, that means oxidation, right? Oxidation. The equation will be similar to this one. Zinc solid Zn2 plus aqueous plus 2 electron. Okay? Likha, have you written it?
Yes, sir.
Then you know very well when oxidation is taking place, simultaneously what should take place? Reduction. And what is other material? Copper 2 plus. Behind of that, copper 2 plus, copper 2 plus aqueous, copper 2 plus aqueous. It is written here. Copper 2 plus aqueous, and it is taking 2 electrons. 2 electrons are given by zinc, converted into copper solid, and then this copper solid is going to settle at the bottom. So
Reduction.
this is reduction, no, right? It is reduction. Now let me come to the conclusion. देखिए अभी हो क्या रहा है? Think here. Which color solution is there?
Blue color.
Blue. Blue color is due to copper 2 plus, but that copper 2 plus is undergoing reduction. So slowly what is going to happen? The blue color will disappear, fade away. Okay. Copper starts to settle down into the bottom inside. And zinc rod is giving what? Zinc 2 plus, losing 2 electron and Zn2 plus. So that rod, electrode or strip starts dissolve. Okay, one side dissolution, one side deposition. Zinc rod is going to dissolve a little bit, and copper 2 plus starts to deposit. Okay, got it? But what is the main thing? Zinc is giving electron, copper is taking electron, but this giving and gain of electron is taking place immediately in the solution. Listen it again, this is the major point. Here, zinc 2 plus is giving electron by the process of oxidation, immediately copper 2 plus is taking electron by the process of reduction. Electron is moving but instantly. We cannot get the benefit of that. That means redox reaction is happening, but this is called a direct redox. Expect it, right? So then what is happening? This oxidation reduction is happening simultaneously. You cannot get the advantage of it. Now you focus it. Think over it. Now we have separated these two parts. Imagine in the first compartment, we have separated zinc electrode. Now zinc electrode is dipped in zinc sulfate. Second side, copper electrode is dipped in copper sulfate. Okay, copper sulfate solution would be which color? Blue. Here is zinc sulfate, colorless. Okay, and both the containers are connected with a simple glass rod which is bent in the form of a U shape, and this U shape is having certain salts. That's why it is called salt plate, like AC here we have put into it. And the external circuit is connected with a bulb. So now imagine. Now you can compare. In the beginning, what was happening? Zinc was giving electron, and that is immediately captured by copper. But now it is not happening immediately. Here zinc is giving electron, zinc is giving electron, and then these electrons are traveling external circuit, and this movement of electron, movement of charge particle will lead to flow of current, and that current is resulted as flow of. So this is called indirect redox. because oxidation reduction is not happening in a single place. I'm not telling single, it is happening in a single compartment. So this is the basis. You can compare what is happening. Earlier electrons were traveling in the same container, but here in two different containers. So this is what part of the खाली है वाले सीट डिस्टर्ब कर रहे हैं अच्छा लगेगा so what is happening you can now compare see that what is happening this zinc giving electron which process is happening oxidation second side what is happening reduction okay but always keep in your mind always it is not going to happen like that that means we can do in a simple miniature form but both are separated by a layer that happens in different button cells mercury cells but now what is happening and how it is converted into a fruitful form the fruitful form is electrons are moving in which circuit internal or external external this is the most important part and that compartment which is on left side it is a source of electron that's why its polarity is negative second side is taking the electron its polarity is positive but it is called anode which is opposite of our normal process and here is what cathode so we can say we have two compartments anode and cathode anode is losing electron or gaining electron losing cathode is gaining ये बॉयज इधर उधर ब्लैक बोर्ड ग्रीन बोर्ड so this is the important factor what is happening तो सभी सेल में ऐसा इवन मोबाइल में जो लिथियम आयन बैटरी है ना सेम थिंग इज that means there should be one container one container electrolyte that is solution which is having ions then anode then cathode and the circuit the whole circuit should be complete also then here you can see here zinc in connection with Zn2 plus zinc in connection with Zn2 plus but the main question is why zinc is giving electron copper is taking electrons when zinc alone is there is no flow of electron okay when zinc is coming in contact with Zn2 plus it starts with certain tendency to lose the electrons and opposite of that when copper is coming in contact with copper 2 plus it is having tendency to accept the electrons so that means you can say in normal words when we are alone we are normal but when we are in contact with our friends we are supernormal so that means here what is happening one tendency generated both the side one tendency is giving according to one tendency electrons are giving by the electrode and second is gaining the electrode and because of this tendency there is flow of electron and the very simple imagination visualization you can do the water level when both are at equal level no flow of water when we are creating the difference ठीक है समझा so then what is happening water starts to water starts to flow. In physics, you are studying it as a potential difference. So here is the difference in tendency. The tendency is scientifically known as potential difference. If the potential difference is not there, that means after a certain time, the bulb starts to dim. Why? Because the tendency of losing the electron and gaining the electron is going to be equalized. That is at equilibrium. Then फिर क्या होगा? Cell function is finished. And second option is what? You push little bit extra current from outside, recharge. It will start to work again. ठीक है ना? So there are two types of cells or batteries. One is use and throw. Second is recharge. You know it very well. But to charge it, can we imagine more potential is required or less potential is required? More potential is required. Because that potential will force it to reverse the reactions and be ready for it. So this is called the basic idea about it. And the same, this process where what is happening, this chemical energy is converted into which energy? Electrical. This is the fundamental of electron. That is from one part to second part, electrons are moving. This is the fundamental where we put our focus is that how electrons are flowing. And that simple zinc copper cell, it is called zinc 2 cell also. This is called Daniel cell. Which cell? Daniel cell. So this is the Daniel cell. Simple example of Daniel cell. Where zinc and copper both are connected. This is the very fundamental visualization and diagram you should keep in your mind. Now let me ask certain question based on this. आप देख लो फिर मैं क्वेश्चन पूछता हूँ. Just see that and I'm asking certain questions. हाँ, salt bridge you can imagine it is joining two containers. The very first function and second idea is what at the left side. What is going to happen? Zn is going as a Zn2 plus 2 electron. Simultaneously concentration of Zn2 plus will increase and second side the concentration of copper 2 plus will decrease. So we have to maintain that. So in the salt bridge, that salt we are taking like KCl. KCl is having two types of ion, K plus and Cl minus. They will move in opposite direction to maintain this concentration difference. So here we cannot select any salt. We should have that salt which is having ions, the ions which can move with equal speeds. That is its ionic mobility. It is called transport number. This is significant. And based on that, all the batteries, all the cells we can develop.
What happens if the speed is not equal?
There would not be maintenance of equilibrium. Okay. Suppose I am telling something, but you are not able to write. I am telling a speed fast. You are not able to write. You will miss something. So here the equilibrium, the concentration difference will not match. If concentration is not matching, then internal current starts to flow, which is not favorable condition. That means instead of external circuit, internal circuit starts to work. Our purpose is defeated. So this is the main idea. Okay, let me ask questions. Ready? name the electrode on right side. Copper electrode, cathode. How can you name the copper electrode? What do you mean by copper electrode? कोई भी बोल लो, गलत होगा, no issue. Copper electrode means copper in contact with copper 2 plus. And what do you mean by zinc electrode? Now the question of IIT. What do you mean by silver electrode? Silver electrode. Ag in contact with Ag plus. And Ag plus may come from AgCl, AgN. Yes, AgP. Now tell me about mercury electrode.
In contact with
Hg in contact with Hg plus or Hg. So you must know the meaning of electrode. Electrode means it is not like that metal stick, metal rod. It is a metal rod in contact with certain ions. Now, what do you mean by everything? Zinc in contact with Zn2 plus. Copper in contact with Cu2 plus. Can you imagine zinc will work in contact with copper 2 plus? Yes, they can show all experiment. Can Ag will work in contact with ZnSO4? Yes, it can work. But would be the more favorable when zinc in contact with Zn2. As we are in the same pattern, scientists are developing the different electrodes. One most important electrode right now. Hydrogen electrode. Hydrogen electrode. Hydrogen electrode. In the short form, क्या लिखेंगे? हाइड्रोजन इलेक्ट्रोड को शॉर्ट लिखो. पहले लिखो. In the short form, it is called He. Okay. But when we are making certain standard condition, temperature we are taking 25 degrees Celsius. Okay, pressure on atmosphere pressure, concentration 1 m. So this E will become normal hydrogen electrode or hydrogen electrode. When we are making it at a standard condition, क्या बोलेंगे? हाइड्रोजन इलेक्ट्रोड के सामने क्या वर्ड लगाओ? स्टैंडर्ड. क्या वर्ड गया? स्टैंडर्ड हाइड्रोजन इलेक्ट्रोड. Or in a funny way, what we can say, when he is becoming standard, it is becoming yes. Hydrogen electrode and standard hydrogen electrode. Okay. This hydrogen electrode is also having certain tendency to lose or gain the electron, right? And now, one second. Discovery vertical. Yes, you can see that. This electrochemical cell. What is happening in electrochemical cell? Recall. What is happening in electrochemical cell? See that chemical energy is converted into electric, and it is fundamentally based on indirect. That means both are happening in separate compartments, chambers or vessels. But how we are writing? So thoda niche. Yes, observe this Daniel cell. How it is written. Observe it. Zinc, a vertical line, then Zn2 plus. Vertical line, what it is showing, you can imagine it out. Zinc is solid and zinc sulfate is in which state? Aqueous. It is called a boundary, phase boundary, which is telling different physical states. Similarly, the double line is indicating to salt bridge, and there is on the left side we have the zinc electrode, and the right side is which electrode? Copper. Copper in contact with Cu2 plus. Cu in contact with copper 2 plus. This is the standard way to represent the cell. How we can write it? This is the way. So, thoda niche kar. Now see the step 2. What is happening? Anode beside this, anode beside left side. Okay, what is happening there? Oxidation. And the example is in front of you. Zn giving Zn2 plus and 2 electron. And now little the part B. What is happening? Cathode right side and reduction. An example is also in front of you. Now come to step 3. In step 3, we are joining these. Next page. Yes, this one. Now we are joining left cell, right cell. Left cell, right cell. Now you can observe the net cell equation. So that left equation and right equation, they are called half equation, half cell reaction, half compartment reactions, and we are joining them and converted into a full reaction. Full reaction. Now let me answer which is working as an oxidizing agent. Which is working as an oxidizing agent? Copper or copper 2 plus? Sure. Undergoing? Which is working as a reductant? Zinc or zinc 2 plus? Which is undergoing? Which is being reduced?
Zinc.
Copper 2 plus. Copper 2 plus is reduced, converted into copper. Okay. Sir, go up. This is one more example. Which cell? Copper and silver cell. Yes.
In the first equation, what is the C1 and C2?
C1, C2 means the very simple thing. In the first container you are having what? Zinc dipped in zinc sulfate. Second side copper dipped in copper sulfate. The solution we are having zinc sulfate, copper sulfate is having certain concentration. That concentration is C1, C2, M1, M2 like that. This is the second example. And how can we write this one? Copper undergoing oxidation. Now copper is undergoing oxidation. Copper is undergoing oxidation. And silver is undergoing reduction. We talk over it. And the overall equation, how we develop overall equation? Because in silver equation, in the equation of silver, we have multiplied by 2. Why? Because we want to maintain the equilibrium. We want to maintain the electrons. So that's why the final equation is zinc, copper, Ag plus 2 Ag plus converted into copper 2 plus and 2 Kc. This is a very simplest idea we must know how to balance, and it is connected with balancing the redox reaction also as well. See, now see this one. This is a little bit different. Here chromium is converted into chromium 3 plus by losing 3 electron, and SN4 which is stannous or stannic? Stannic converted into stannic. Undergoing reduction, oxidation, reduction. So one side 3 electron, second side 2 electron, not 3 or 2 moles of electron, 3 moles of electron. ठीक है सिद्धार्थ? So then this is our overall equation. This is our, and you can imagine, you can see the number of electron exchange, 6 moles and equal to what? 6 moles of electrons. That is the fundamental picture of quantum. Next, X. So diagram you got to. Now you write the equation that will help you to recall. लिखो loan 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 नहीं सुना है? सब लोग लेते थे loan is taken सबसे अच्छा बैंक कौन सा SBI loan is taken from SBI loan is taken from which bank SBI to purchase red cat to purchase a red cat cat CLT cat to purchase a red cat with a positive idea So now correlate loan L for which side? Left side. What is happening? Oxidation. LO left side oxidation. A means anode. N means कैसा polarity है उसका? Negative. Loan means you got it. Left side oxidation, anode and negative. ठीक है? और सेंटर में क्या है? Salt bridge. So SBI is indicating salt bridge. Which substance? Ionic. SBI is indicating salt bridge ionic. In which form it is? Ionic form. Okay. Now come to the next part. Red मतलब reduction. Red मतलब reduction is happening at which electrode? Cathode. And its polarity is positive. Okay. So this is the idea that we can, what it is called mnemonics, short forms, through that we can recall, we can retain in our mind how it is happening. Okay. So this is our right idea to purchase a red cat through SBI by taking a loan. Right. So then ये लोग रिवर्ट भी पढ़ लेते हैं रिवर्ट भी चलेगा पढ़ना इसलिए मैंने रिवर्ट सिखाया था yes this part now the left side that means zinc electrode and copper electrode both are having certain tendency मतलब tendency either to lose electron or gain electron that tendency is technically what it is called electrode potential. This tendency is technically called which potential? Electrode potential. That means one electrode is giving is which potential? Giving is oxidation potential. Gaining is reduction potential. Okay. And because of difference in potential, electrons are moving, flowing. Okay. But how can we come to know? How can we come to know this electrode is having a particular tendency? We measure with a particular electrode. That I will tell you. But before that, here we have written a formula. How can we calculate the overall tendency of the cell? The formula is E standard of cell, potential of right compartment minus, it is not divided by, it is In case of right or left, we can write cathode and anode. Note down this formula. Question will be asked by using this formula. E is E is electromotive force. That force through which electrons are moving in a particular direction. It is electrode potential. So here the formula is there. Here formula is there. Right minus left. We can write right minus left, or we can write cathode minus anode. Both will work simultaneously without any issue. And the formula. Yes, it is little bit tougher side, but not that much complicated. It is the way how can we write the particular cell is working. How this cell is working, how the potential is generated. So this is a simple equation. It is called which equation? Nernst equation. How it is written, the format is in front of you. No need to go into detail, just you have to see this, how it is working, how we are writing. This is the main item. But before that, write again, write E standard of cell. E standard of cell. So thoda niche. Step 4. In that pattern, write that formula. E standard of cell is equal to E standard of right minus E standard of left. ओके, अब उसके नीचे लिखेंगे डायग्राम में. Yes. Now you can observe what is written. How we can write it. This is important part. Whatever I'm telling, write in that E standard. E standard. देखो E के ऊपर एक नॉट लगाओ. E के ऊपर एक जीरो लगाओ. बस इसमें E नॉट. अब सबस्क्रिप्ट समझ में ना नीचे लिखना. E के सबस्क्रिप्ट में लिखो जिंक ऑब्लिक जिंक मतलब Zn जिंक ऑब्लिक जिंक 2 प्लस E standard ऑफ सेल लिखा तुमने. उसके सबस्क्रिप्ट में लिखा जिंक ऑब्लिक Zn 2 प्लस इज इक्वल टू minus is equal to minus 0.76 volt. 0.76 volt. Okay. Similarly, E standard of copper. E standard of copper 2 plus oblique copper. E standard of copper 2 plus oblique copper is equal to 0.34 volt. Apply this formula. Apply this both the part in the equation. E standard और मुझे वैल्यू बोल. Apply. So what is the value? 1.1 volt. Then you can observe here. E standard of cell equal to standard of right minus E standard of left. But you are getting 1.10 volt.
1.1 volt.
E is from Mars. It is 1 point which volt? 1.10 volt. ठीक है? एक और सॉल्व करो. अभी E standard of silver लिखो. E standard of silver कैसे लिखेंगे? E standard of Ag plus oblique Ag. E standard of Ag oblique A equal to 0.80 volt. Okay, and E standard of कॉपर तो लिखा ही है. अगर मैं कॉपर और सिल्वर का सेल बनाता हूं, देखा था ना, आउटपुट बोलो कितना है.
कैसे कॉपर का
Copper should be, copper will work as a, copper will work as a anode, silver will work as a cathode. Output बोलो. 0.46. You got how it is calculated? सब ऊपर आ गया. Now you can see that. So this is E cell. Nernst equation is E cell equal to E standard of cell minus 0.0595 m. You know the log function? In the math we have done log function. You know the log function, नहीं?
log
LOG. सबको आता है log function? You know the log S10, log SE. So then it is log, and here what is at the top? At the numerator is coming from that equation. If our equation is correct, right, then we can write this equation. Otherwise, we cannot write. And that equation does that right net cell equation. Net cell equation comes from two half equations. That is anode and cathode. If we are not able to write it, we cannot come to this net equation and we cannot write the numbers. All are very well connected in a sequence. That's why step 1, 2, 3, 4, 5 is mentioned. Okay. So this is the equation, and from where the 0.059 is coming, it is 2.303 RT by NF. R you know? Gas constant. Okay. F you know F. Faraday's. Have you heard about Faraday's? No. उधर लिखो कॉपी में लिखो. 1 Faraday is equal to 1 Faraday equal to charge on 1 F. Facebook वाला F नहीं. 1 F. 1 F charge on 1 mole electrons. Charge on 1 mole electrons. Charge on 1 mole electron. So how can we calculate? Charge on 1 electron is equal to 1.6 10 to the power minus 19 coulomb. लिखो कॉपी में लिखो. 1.6 into 10 to the power minus 19 is into 6.1 mole. One mole is 6.023 into 10 to the power 23. Right? So it is around 9650 coulomb. It comes around 9650 coulomb. That means this is the value of F. Okay, we'll talk also. So this is the next way. This is the way how we are calculating. Further is, this is very important term, Gibbs free energy. Have you done a little bit thermodynamics? Thermodynamics कराया ना सर ने? नहीं कराया. Entropy, what's the entropy? सबने सुना एंट्रोपी वर्ड? नहीं, चलो ठीक है. Let me connect the name in which energy gives free energy. The simplest idea, the full energy of the fuel cannot be converted into certain form. Some energy is going as a waste, some energy is going in a side process. The remaining energy which is available for doing work is called free energy. This is this is explained by Gibbs. It is called Gibbs free energy, and this Gibbs free energy is related to work done. This Gibbs free energy is related to work done. Or which type of work is happening here? Homework, classwork, or mechanical work, or electrical work. Electrical work. Which work? Electrical work. And that electrical work, how can we calculate? The formula is in front of you. NF, NF means N number, F is Faraday, E is electrode, overall cell potential, electromotive force. एक सेल कितना काम कर सकता है? All the values are put together. That is called work done. Gives the energy in the form of work done. And the last step is little bit higher side, but you can easily tackle it. Calculation of equilibrium constant. सर लास्ट इक्वेशन पे वापस आएंगे. बस this is that. Now imagine in the beginning cell starts to work. What is the result of it? The bulb will मुझे बोलना पड़ेगा कि मेरा आपको कष्ट दे रहा है. नमस्कार मिस्टर मिनी. तो what will happen after certain time? क्या बल्ब कंटिन्यू ग्लो करता रहेगा क्या? No. It starts to that means what is happening? Equilibrium is reached. Cell will function? No. Cell will function? No. So in that equation, इधर in that equation, what we should take as a zero? E standard or E cell? E cell. Standard का कभी zero नहीं आता. Standard is standard. E cell would be zero. That means E standard of cell will be equal to this part. And in this part, which is written with log, it will be reaching a equilibrium situation. Yes. So that's why we are replacing. See the condition. E standard of cell is equal to 2.303 RT by NF log AC, and it is what is mentioned here? At equilibrium, E cell is C. E cell is C. So this is the general equation of that. You can easily imagine it out. Let's go back. इसको अभी हम देखें. ठीक है, यहाँ तक हमारा डाउट है. You can ask your doubts. Otherwise, I will ask the questions. You are having doubts. You can ask your doubt. एक सेल कैसे काम करता है? क्या प्रॉब्लम होता है? But a simple visualization should be in your mind. Otherwise, I'm going to ask certain question based on that. नर्स वाला इक्वेशन वापस दिखा देते हैं. Yes. Nernst equation is a simple way through which we want to know how cell is working. If you imagine this equation, E standard of cell means जो भी हमने condition ली है, minus we are subtracting something. We are subtracting something means the simple example we can say. Very simple example is what? Suppose we are having a bike of 100 cc. समझते हैं बाइक का कैपेसिटी होगा ना 100 cc और उसका एक माइलेज होगा. हमने बाइक लिया 400 cc का, माइलेज बढ़ेगा कम होगा, ठीक है ना. So similarly, out of this standard one, ions are moving. When ions are moving, collision will be there, viscosity would be there, temperature would be there, nature of ion would be there, smaller ion, bigger ion. So we are subtracting other things. But the remaining one, we are getting E cell. That E cell will help us to calculate the work done. कितना उससे कितना work done, कितना energy produced होगा. Because this chemical energy is converted into electrical energy. This is the Nernst equation which is helping us. It is a mathematical. Yes, fully over out. E standard means ideal conditions. We are taking this. It is like that. You are observing the different types. This bike is giving, this car is giving that mileage. But in normal road condition, we are not getting that mileage. So that is standard lab conditions. But when our bike car is moving in normal road conditions, it is not giving that mileage. That means out of this standard, some problem is happening, and because of that, actual potential is not obtained, a little bit lesser potential is obtained. This is the difference. Yes, only good doubt. If you are having any doubt, everything is mentioned in steps so that you can follow the steps. हाँ देखिए, ये इस सब का यूटिलिटी क्या है? इस सब का यूटिलिटी क्या है? The very simplest example we can take. हमें अपने घर में इन्वर्टर लगाना है. You know the inverter? What is the function of inverter? If the normal electricity is not running, we are using as a backup. And that inverter capacity is there. How it is calculated? कितना रूम्स है, कितना फैन चलाना है, कितना ट्यूबलाइट चलाएंगे, टीवी चलाएंगे, फ्रिज चलाएंगे. Particular load is there. हमें पता है 1 kilowatt load है, 2 kilowatt load है. Accordingly, we are installing the inverter. But that inverter or a battery, we are using a battery. In inverter battery, battery कितना capacity का है? 2 volt, 10 volt, 12 volt, 24 volt. Like that, this redox reaction is helping in a multiple way. One of the application, electrochemicals are directly helpful in formation of batteries. How this battery will help? एक बैटरी का आउटपुट कितना आएगा? That can be done through this process, and accordingly we can use the different devices. It is the application of redox in our day-to-day life. ठीक, और बोलिए जो लॉग वाला पार्ट. हाँ देखिए, अभी ये लॉग इस इक्वेशन को जो अभी we are not going to derive this equation, but we are just keeping that equation, this log. That means certain parts should be reduced. Why it is reduced? Why it is reduced? Because ions will collide. The size of ion is also there is important matter. Sodium छोटा size होगा, sulfate थोड़ा बड़ा size होगा, phosphate होगा और बड़ा size होगा. And these ions are forming the clusters. These clusters will move in different directions. That means जितना हमारा imagination है, all imagination, all theoretical will not work practically. That's why we are taking a subtraction part. बोलिए और क्या करना है? हाँ बोलो. In that, in salt bridge, our intention is to take that salt. That salt is having that ions, which can move with equal speed in both directions. Because concentration difference is left and right condition. They are not moving with equal speeds, equal mobility speed. That means the concentration difference is not maintained. That will not work. The left side added to the concentration is increasing, and opposite side forward to the concentration is increasing. This cation is having cation as well as anion both are. Yes, बच्चों बोलिए और किधर डाउट है? मैडम 45 तक है ना? क्लास का टाइम क्या है? 45 ठीक है. Now come to the second part.
The practical का कोई
हाँ प्रैक्टिकल का भी बताऊंगा. प्रैक्टिकल भी करेंगे. चिंता मत. चलिए इसके बाद लिखिए राइट डाउन Faraday's law of electrolysis. राइट डाउन Faraday's law of electrolysis. ये थोड़ा सा लिखा हूं Faraday's law of electrolysis. इसमें ये एग्जांपल है इसका, ठीक है. Faraday's law of electrolysis. Right, first law. Faraday's first law. Faraday's first law. The heading is Faraday's law of electrolysis. में हम first law लिखेंगे, but उससे पहले लिखिए note NOTE note. During electrolysis, electrochemical cell में which energy converted into which form? Chemical energy into electron. इसमें revert.
during electrolysis.
During electrolysis, अभी बोला ना? Electrical energy into chemical energy. मतलब पहले क्या था? Chemical energy से electrical energy बन रहा था. अभी हम बाहर से electrical energy देंगे, कुछ chemical changes होंगे. Second लिखेंगे at anode पे कौन सा प्रोसेस? ऑक्सीडेशन. ठीक है, at anode oxidation. ब्रैकेट में लिखिए पॉजिटिव, उसकी पोलैरिटी पॉजिटिव नॉर्मली रहेगा, और जेनियल सेल में अपोजिट था, ठीक है ना. सेकंड पार्ट लिखेंगे at cathode कैसा होगा अभी पोलैरिटी नेगेटिव ब्रैकेट में नेगेटिव लिखेंगे रिडक्शन लिखेंगे एंड डिसोल्यूशन और लिबरेशन और लिबरेशन एक तरफ एनोड क्या होगा नहीं गलत लिखा एनोड पर लिखो डिसोल्यूशन एनोड डिसोल्यूशन लिबरेशन कैथोड पर लिखो डिपोजिशन कैथोड डिपोजिशन एनोड लिबरेशन मेल्टिंग डिसॉल्विंग ठीक है now next line it is quantitative analysis
श्री नोट्स में चल रहा है
it is quantitative analysis notes ही चल रही है
नहीं सर आपने बोला था नोट ड्यूरिंग
हाँ ठीक है that is all इतना हो गया एनोड पर क्या होगा एनोड में लिबरेशन होगा मेल्टिंग होगा कैथोड पर डिपोजिशन होगा ठीक है now write small w
it is
नीचे एक नया लाइन में लिखिए स्मॉल w proportional to directly proportional to small w directly proportional to q capital Q अब जैसे ये क्या है w किसको बता रहा है अमाउंट कौन सा अमाउंट which is either deposited or liberated जितना मेल्ट हो रहा है या डिपॉजिट हो रहा है उसके लिए हम क्या वर्ड ले रहे हैं w किसके ऊपर डिपेंड करेगा जितना हम क्या दे रहे हैं q बाहर से हम कौन सा एनर्जी दे रहे हैं इन द फॉर्म ऑफ चार्ज तो जितना चार्ज फ्लो करेंगे उतना डिपॉजिट या लिबरेट हो ठीक है नहीं आया समझ में हाँ देखो बहुत सिंपल सी बात है ये इलेक्ट्रोड है हमने डिप किया या तो ऑक्सीडेशन रिडक्शन जोन होगा एक साइड ऑक्सीडेशन एक साइड रिडक्शन ये वाला लोड क्या होगा ये वाला इलेक्ट्रोड क्या होगा थोड़ा मेल्ट होगा इसमें से कुछ डिसॉल्व हो गया और इधर से उधर जाके रिडक्शन होगा तो क्या कुछ डिपॉजिट होगा तो कितना अमाउंट डिपॉजिट हुआ कितना अमाउंट लिबरेट हुआ दैट वी वांट टू कैलकुलेट बट what is the driving force behind it so liberate or deposit क्यों हो रहा है because what we are giving from outside सीधा concept what we are giving from outside electrical energy but electric energy is forcing for oxidation and reduction तो जितना अमाउंट डिपॉजिट हो रहा है लिबरेट हो रहा है डिपेंडिंग अपॉन what electrical energy given from outside और इलेक्ट्रिकल एनर्जी का कैसे किसकी फॉर्म में Q की फॉर्म में तो W प्रोपोर्शनल टू क्या हो गया Q ओके देन W इज इक्वल टू W प्रोपोर्शनल टू वो कर लिया ना W इज इक्वल टू नाउ वी वांट टू रिमूव द साइन ऑफ प्रोपोर्शनलिटी इट इज कॉल्ड Z W equal to Z capital Z Q और Q तो सबको पता है since Q is equal to IT I into T because since Q is equal to IT I क्या हुआ
करंट
नहीं, जब मैं दोबारा से बोलता हूँ W इज इक्वल टू क्या लिखा W प्रोपोर्शनल टू Q, W इज इक्वल टू ZQ, since Q इक्वल टू I is current in amperes, T is time in seconds. लिखो time in seconds. I is equal to current in amperes and T is time in second. Next line will be hence W is equal to ZIT zit. ठीक है, और we can say it's IP Z zit it's जैसा भी याद रहेगा वैसा हम लिख सकते हैं, ठीक है। हाँ, देखो Z is called electrochemical equivalent. Electrochemical equivalent equal to equivalent के बाद इक्वल का साइन लिखो, बनाओ कैपिटल A divided by small n for naughty, ठीक है ना, into नीचे डिनोमिनेटर में n into f, z is equal to a by denominator में n into f. Okay, f का what is that? Response कितना वैल्यू 96500, ठीक है। नेक्स्ट लाइन में लिखो W is equal to A by NF A by NF, A by NF पहले बोला ना कि Z का वैल्यू हम रिप्लेसिंग कर Z into IT, नेक्स्ट लाइन में लिखो, नेक्स्ट इसको याद रखने के लिए ऐसे होता है, थोड़ा देर केमिस्ट्री पढ़ेंगे लिखो नेक्स्ट लाइन में लिखो it's enough इंग्लिश वाले it's enough my way, हाँ वेट किसको बता रहा है W को, it's किसको बता रहा है IT को, और NF किसको बता रहा है, मैं सोचा तुम लोग तो सुपर इंटेलिजेंट हो। हाँ it's enough my weight या my weight is enough, जैसा भी तुम्हें याद रखना है you can recall it, your weight is enough. Next line और ये जितने भी पूरे निमोनिक्स बताए ना उनको याद करने का सबसे अच्छा टेक्निक होता है सेल योर प्रोडक्ट। सेल योर प्रोडक्ट मतलब अपने घर में किसी को भी पकड़ो, वो सुनना चाहे नहीं सुनना चाहे सुना दो, तुम्हें याद हो जाएगा, भले उसको याद हो नहीं हो। और कोई भी अगर मैं किसी को भी पकड़ लो तो रास्ते में मत पकड़ना किसी को भी, ठीक है ना? हाँ हाँ वही बोल रहा हूँ। नेक्स्ट लिखो लिखो, एक एग्जांपल लिखो। एग्जांपल if 5 ampere current, if 5 ampere current, if 5 ampere current is passed 5 ampere, if 5 ampere current is passed for 5 minutes, if 5 ampere current is passed for 5 minutes in the solution of copper sulfate, in the solution of copper sulfate, find out the weight of copper deposited, weight of copper deposited. A is atomic number and copper 2 प्लस होता है ना, कितना इलेक्ट्रॉन लूज करेगा या गेन करेगा 2, F का वैल्यू पता है, एंड कॉपर कितना इलेक्ट्रॉन लूज करेगा 2 ना, कॉपर 2 प्लस। थोड़ा आइडिया लगा कैलकुलेट करो। W will be A का वैल्यू, what is the value of A in copper? 63.5 divided by, करो चेक, sorry atomic weight, A is atomic weight 63.5 divided by and कॉपर में कितना होगा 2 और F वैल्यू 96500 कूलम, ओके। I वैल्यू 5 T 5 into 60, 5 into 60, ठीक है? Can you calculate? ठीक है, you can calculate. अभी नेक्स्ट लाइन में लिखो W, in the next line W, next line W. सर बस हाँ लिखो W is equal to, लिखो फिर वॉल्यूम होता है W, ठीक है? इधर क्या था, A by NF था ना, now write W by A, next line W by A, उधर से A को इधर डिनोमिनेटर में शिफ्ट किया, W by A is equal to number of moles, weight by atomic weight is number of moles is equal to, अभी क्या फॉर्मूला बचेगा, IT by NF, IT by NF. In the next line Z is equal to A by NF था ना, A by NF था ना, A by N को रिप्लेस करो कैपिटल E से, now Z will be E by F, E को एरो लगाकर लिखो, इक्विवेलेंट क्या हो जाएगा, एटॉमिक वेट बाई वैलेंसी क्या हो जाएगा? इक्विवेलेंट वेट, इक्विवेलेंट वेट। जेड वो था जो लास्ट में आता है। Z was called as electrochemical equivalent. So Z is now what? E by F. Write one more equation. Copper 2 plus 2 electron plus 2 electron 2 E लिखना है, इलेक्ट्रॉन नहीं लिखना है, 2 E giving copper। देखा? कॉपर का प्रीफिक्स कितना है? 1। कॉपर का प्रीफिक्स कितना है? 1। इलेक्ट्रॉन 2, इधर कॉपर के नीचे कॉपर 2 प्लस 2 इलेक्ट्रॉन कॉपर। ओके, कॉपर 2 प्लस लिखा ना, कॉपर 2 प्लस 2 इलेक्ट्रॉन गिविंग कॉपर। ठीक है, अभी कॉपर 2 प्लस का प्रीफिक्स इज 1, इलेक्ट्रॉन प्रीफिक्स 2 एंड कॉपर 1। कॉपर 2 प्लस के नीचे लिखो 1 मोल, कॉपर 2 प्लस के नीचे लिखो 1 मोल, 1 मोल, डोंट राइट 1 मोल, राइट 1 मोल। ठीक है ना, डोंट राइट 1 मोल, राइट 1 मोल। 2 इलेक्ट्रॉन के नीचे कितने मोल? 2 1 मोल। ठीक है, 2 मोल, और उधर कितना? 1 मोल, अगेन 1 मोल, 1 मोल। ठीक है, और अभी बोला था 1 मोल इलेक्ट्रॉन इक्वल टू कितना फैराड है? 1 फैराड। इधर कितना फैराड है? कितना फैराड है? 2 फैराड। तो 2 मोल के नीचे लिखो 2 फैराड। लिखा 2 फैराड है। तो अभी सीधा क्वेश्चन है, एल्यूमिनियम वाला इक्वेशन लिख के लिखा हुआ है। एल्यूमिनियम का इक्वेशन लिखो, रिडक्शन Al3 plus 3 electrons giving air। कितना फैराड है? 3 फैराड। कितना एल्यूमिनियम डिपॉजिट होगा? एल्यूमिनियम वेट कितने ग्राम? 27 ग्राम, राइट। कितने ग्राम? अब एक क्वेश्चन लिखो, 200 ग्राम कैल्शियम डिपॉजिट करना है। 200 ग्राम कैल्शियम डिपॉजिट करना है। We want to deposit 200 ग्राम कैल्शियम, कितने फैराड चाहिए? करो, कैलकुलेट करो। 200 ग्राम, और क्वेश्चन नहीं है, अपने क्वेश्चन में कैलकुलेशन नहीं है। इक्वेशन क्या बनेगा कैल्शियम का? हाँ, कैल्शियम का इक्वेशन क्या बनेगा? Ca2 plus 2 इलेक्ट्रॉन गिविंग कैल्शियम। और कैल्शियम कितने ग्राम? 1 मोल कैल्शियम 40 ग्राम। उधर कितने ग्राम है? 200। ठीक है ना, 40 ग्राम इज कमिंग फ्रॉम कितने फैराडे? 2 फैराडे। 200 के लिए 10 फैराड। गॉट इट? These are the simple questions asked. Last equation लिख लो। एक चपाती एक्स्ट्रा खा लो। नेक्स्ट लास्ट इक्वेशन लिखो W, दोबारा से लिखो W इज इक्वल टू A by NF, A by NF into Q। ओके, नेक्स्ट लाइन में W इज इक्वल टू A by N को हमने किससे रिप्लेस किया था? E, कैपिटल E, कैपिटल E divided by F into Q। All are understanding? ये केमिस्ट्री पढ़ने से क्या होगा? ठीक है। नेक्स्ट लाइन, अभी करो W by E करो, W by E, W by E is equal to Q by F। W by E को इमेजिन करो, वेट डिवाइडेड बाय इक्विवेलेंट वेट, नंबर ऑफ इक्विवेलेंट्स। देखो नंबर ऑफ इक्विवेलेंट्स, नंबर ऑफ इक्विवेलेंट्स, नंबर ऑफ इक्विवेलेंट्स इज इक्वल टू क्या हो गया? Q by F। ठीक है, अभी ये जो हमारे पास में टर्म आ रहा है नंबर ऑफ इक्विवेलेंट्स, ठीक है, E by सॉरी Q by F। Q क्या है? IT। Q is what? IT। लिखो if same current, if same current,
Current?
if same current, current, ठीक है, if same current is passed in two different solutions, in two different solutions for same duration, for same duration, ठीक है। तो अब जब डिपोजिशन शुरू होगा, दो सॉल्यूशन इधर वापस सब्सट्रेट है, इधर तीन सब्सट्रेट, हमने सेम करंट पास किया, सेम ड्यूरेशन के लिए पास किया, तो लिखो W1 by W2, W1 by W2 is equal to E1 by E2। W1 by W2 is equal to capital E1 divided by capital E2। जो भी डिपोजिशन होगा वो E क्या है? इक्विवेलेंट वेट, उसके इक्विवेलेंट वेट के अकॉर्डिंग होगा। इसी को ब्रैकेट में लिख लो, सेकंड लॉ ऑफ इलेक्ट्रोलाइसिस, सेकंड लॉ ऑफ इलेक्ट्रोलाइसिस। और जो शुरू में लिखा था तुमने इट्स माय वेट इज या माय वेट इज है ना, वो कौन सा लॉ है? ठीक है, धन्यवाद, थैंक यू। कोई डाउट है तो पूछते हैं ना। अच्छा, ये अगर हमें अपना कनेक्टिविटी बनाना है ना, हमारा न्यूरॉन का रिलीज बढ़ जाता है। इसमें ये ऐसे ब्रेन एक्सरसाइज भी होता है, ऐसे ही करते हैं ना, ऐसा गेज करके करते हैं, कोऑर्डिनेशन करते हैं। ठीक है, थैंक यू सो मच, थैंक यू। मेरा